All right, so we're going to go ahead and get started here. So today we're doing 2 days on this section. We do, I'm trying to think if I gave you the entire packet. I think we did. I think I did. So you can see how far I get to today. And then it looks like slide 8 we get to today. And then we do 6 tomorrow. Okay, so we are going to start out today. We're not going to actually graph any polynomials till tomorrow, but we're going to look at polynomials today. And we are going to decide kind of what they do on each side of the graph. That's one of the things that we're going to learn. We're going to talk about, first of all, one of the things they're going to ask us for is this a polynomial in one variable? Okay. And if it is, we have to state the degree, which we've done before. But when we did it before, we had 2 variables, okay? This time is going to be even easier because it only has 1 variable. And we're going to find the leading coefficient. So here are some different equations. A constant equation is just like y equals some number. That would have a degree of 0. And the leading coefficient for that is what is in front of, it's usually what's in front of your highest powered variable, okay? Well, in this case, the only thing we have is 12, so that would be our leading coefficient. This would be, if you graphed it, just a straight line. And the highest powered variable here would just be 1, and 4 is in front of that. So 4 is my leading coefficient, 1 is my degree. Here we have a quadratic, which we just spent a whole chapter on, and that is going to look kind of like a parabola, okay? So when you're looking at this, you look for highest power, which is 2. Leading coefficient is what's in front of that. So our degree is 2, our leading coefficient is 5, okay? A cubic equation is one that has the highest power 3, and so this degree would be 3, and notice these are all less, and then the leading coefficient is 8. And then just for general, one of the things that you'll notice as we do these problems, they don't always put the variables in descending order, so they'll sometimes go like 8 minus 2x to the 5th plus x to the 3rd minus x to the 4th, something like that. You don't necessarily have to rewrite this. You would just have to look for your highest power of x to get your degree, okay, which in this case would be the 5. And your leading coefficient is going to be the number in front of that with the sign. So it'd be -2. Okay. All right. So one of the things you have to say is this a polynomial in one variable? Okay. So we talked a couple, maybe like last week, about what made something a polynomial. And one of the things was if you had a variable on the bottom, if you had a variable to a negative power, if you had a variable as a power, those are all ways to make it not a polynomial in one variable, okay? Now, if you look here, when they say polynomial in one variable, you just want to make sure every one of those things has just an x, no y's, no z's, nothing like that, okay? So this is a polynomial in one variable. If it is, then you say what the degree is. What's the degree of this one? 5, yep, that's the highest power, and the leading coefficient is the 8. And this we wouldn't have to do because it is a polynomial. How about this next one? Is it a polynomial in one variable? No, because of this xy, so down here we'll just say xy term. And then you don't worry about degree or leading coefficient. How about C? Now this is one that's not in order from big to small powers. So it is a polynomial in one variable. What's the degree? Yep. And what's the leading coefficient? -4. And then you can ignore that. How about D? Because, yep. And then we can just ignore these two. Okay. Now this next one you can't really tell the way it is. So what we're going to have to do there is use FOIL. So we're going to take 5 minus 2y times 4 plus 3y and do FOIL. So we go first terms, 5 times 4 is 20. O in FOIL is outside. 5 times 3y is plus 15y. Inside is negative 2y times 4, which is negative 8y. And then negative 2y times 3y is negative 6y squared. Now you would still want to combine your like terms. So this would be 20. 15y minus 8y is 7y, and then minus 6y squared. So is this a polynomial in one variable? Yes. What is the degree? 2. What is the leading coefficient? -6, and then we don't have to do that. Okay? So those are not too bad. Okay? Now, another thing that we are going to do is that we are going to, this is kind of like the function form for the polynomial. And we did this earlier this year. I don't know if you remember, like your function might have been f of x equals 2x, and they said find f of 2. Do you remember what we did? Yeah, you just plug that 2 in here, and it would be 2 times 2, which is 4. Okay, well, these are a little bit harder just because we have so many powers and stuff, but you still, I mean, that's what you do. So they want to take -4 and put it in everywhere there's an x. Okay, so this is what we would have. 2, and because it's negative, we're going to put it in parentheses. -4 to the 4th power, minus 5, and we're going to put -4 in here to the 3rd power, plus 3, -4 squared, minus 2 times -4, plus 8. Okay, yeah.
Do you think we could plug this all into the calculator?
Yes, you can. So I'm going to go to my calculator, and we are going to punch this in. Okay, so we're going to go 2, so 2 parentheses, -4 parentheses, up arrow 4. And then you have to hit that right key to get down. Minus 5 parentheses, -4 parentheses, up arrow 3. Hit that right arrow again. And then plus 3 parentheses, -4 parentheses, x squared, and then minus 2 parentheses, -4 parentheses. And then at the end, it's plus 8. So as long as you punch that all in, did you guys get 896? Okay, that's all you would have to do for these. They do get a little bit harder because you don't always just put in numbers. And then, like, there's one problem today that we're gonna do that's quite long. Okay, so if we looked at this one, what you would do is put this variable in for x, okay? So when you do that, just this variable, y to the third, goes in for x, and it would be to the 4th power, okay? Minus 6, and then y to the third goes in for the x, and because the x is squared, this has to be squared. And then it's minus 3, okay? Now this one you can't really use your calculator for, but this is not too bad. What do you get when it's y to the third to the 4th? Y to the 12th. You multiply those. Very good. Minus 6. And what if you get y to the third squared? Y to the 6th and minus 3. And then that is your answer. So some of these are not bad, but this very last one we do is kind of a pain. So here's what they want us to do now. You kind of look inside of brackets first, and they want us to take this and put 4z everywhere we see an x. And then they want us to multiply the whole thing by a negative 3. So what I do is this, I keep that negative 3 out and put it in a bracket, and that just tells me all along I have to eventually multiply by a negative 3. Then I have this 2, my x is 4z this time, squared. Minus 5, my x is 4z, and then it's plus 1. Okay. Then what I have, I usually just leave that negative 3 out until the very end, okay? What do you guys think? We could just evaluate this right now. What's 4 squared? Times 2, 32. And if it's something that's hard, just punch that in your calculator. Minus 5 times 4 is 20z, and then plus 1. Okay, now we can't simplify inside of that, so all I have left then is I want to take this negative 3 and distribute it. Okay, so negative 3 times 32 is negative 96z squared. Then negative 3 times negative 20z is plus 60z. And then negative 3 times 1 is minus 3. So that would be our answer. Okay. All right, so now if we go down to this next one, we are going to put negative or 2a in everywhere we see an x, and then we're going to multiply the whole thing by 5. So we have this 5 out there with the bracket. Now this one's a little confusing. You have a negative x cubed, but the negative is not in the parentheses. So it's negative, and then we have 2a cubed plus x is 2a, and then plus 1. Okay. Now, this 5 out here is what we multiplied by. The d is the actual function, and we just put 2a in for each x. So now we just have to simplify. So here we have 5. We're going to still have that minus sign. Do you guys know what 2 cubed is? 8. Yep, 2 times 2 times 2 is 8. And then a to the third plus 2a plus 1. Okay, and then we're just going to distribute. So I'm going to take this 5 times everything. 5 times a negative 8, a to the third is negative 40, a to the third. Plus 5 times 2a is 10a. 5 times 1 is 5. Okay. Now, when you get something like this to put in for your x's, like here, we're going to have to FOIL it. So that becomes more of an issue. And this one down here is the worst one. So everywhere we see an x here, we have to put this a squared minus 1 in. So we're going to have 2 times a squared minus 1. And that is squared because our x is squared. Minus 5 times a squared minus 1, and then plus 1. Okay? So when you do this, this is not just squaring that minus this square. When you have a parentheses with a plus or minus and the whole thing squared, you have to write it down twice, and you have to use FOIL. Okay? Here, I could just distribute this right now. Negative 5 times a squared is negative 5a squared. Negative 5 times negative 1 is plus 5. And then I have my plus 1. Okay? Now, what I would do next is FOIL this. So I'd keep that 2 out there. Okay? Remember FOIL. First, outside, inside last. So we're going to first multiply a squared times a squared, which is a to the fourth. A squared times a negative 1 is minus a squared. Inside is negative 1 times a squared, which is negative a squared. And then a negative 1 times a negative 1 is a plus 1. Okay, and then we still have our negative 5a squared plus 5 plus 1, I can combine to 6. Okay, now what I'm going to do is distribute this 2. I could have combined these 2 first, but that's okay. I'm just going to distribute it. 2 times a to the fourth is 2a to the fourth minus 2 times a squared is 2a squared minus 2a squared again plus 2. And then I'm going to copy this down. Minus 5a squared plus 6. So here we still have that 2a to the fourth. There's nothing else that has an a to the fourth. Do you guys know what a negative 2a squared minus 2a squared minus 5a squared would be?
Negative 9 squared.
Negative 9a squared. Very good. Okay. Then we have 2 plus 6, which is 8. And that is your answer. Okay. So like I said, this one is the worst thing I think we do today. And it's just that you kind of have 2 problems going on together and you're adding them together. It's just really easy to make a mistake. So you have to be careful of that. And like we have an x cubed here, so this can get a little bit ugly. So here we're going to have a negative 2 outside of our c, okay? And we're going to put 3b in here. So we have 4 times 3b cubed, okay? Minus 5 times 3b squared plus 2. Actually, that could have been worse if this had a plus or minus and you had to multiply that 3 times. So that wasn't too bad, actually. And then we're going to go plus, it's not a 5, plus 5 times, and everywhere we see an x in this one, we have to put in 2b minus 4. So we have, do you guys mind if I just write 2b minus 4 twice? Do you guys get that? Because it's squared. And then plus 6 times 2b minus 4, and then minus 10. So the reason I wrote this twice is that it's squared. Now we can just start simplifying, and like I said, it can be hard to not make a mistake. So I would forget about that -2 out there, and at first what I would do is just do this. And do you guys know what 3 cubed is? 3 times 3 times 3 is 27. 27 times 4, 104, I think? 108. Is that right? Yeah, 108. But you can certainly just go 4 times 3 cubed on your calculator too. And then b cubed. Now here, 3 squared is 9. 9 times 5 is 45. B squared plus 2. Okay, so that one's kind of simplified for now. Then we have plus 5. We're going to keep this 3 out right now, and we're going to FOIL this. Okay, so we do the first. 2b times 2b is 4b squared. 2b times a -4 is -8b. Inside is also -8b. And a -4 times a -4 is a +16. Okay. I'm also going to distribute this. 6 times 2b is plus 12b. 6 times a -4 is minus 24, and then minus 10. And this is still in this big bracket multiplied by 5. So like I said, it's very easy to make a mistake on this. So what we're going to do next, we're going to distribute in this one, this -2. So -2 times 108 is -216b to the third. -2 times -45b squared is plus 90b squared. And -2 times +2 is a -4. Okay. Now when I go to this one, I'm going to leave that 5 out front. And I could do this a couple of different ways. I might just right away distribute this 3. I could have rewritten this combining these two, but I'm going to distribute the 3. So 3 times 4b squared is 12b squared. 3 times the -8b is minus 24b. 3 times -8b minus 24b. And 3 times 16 is 48. Okay. Then I have my plus 12b, and I can combine these two. -24 minus 10 is -34. Okay. So now what I have to do is I have to distribute this 5. And then I can start, and I could have combined terms first here. You might have chosen to do that before you distribute the 5. It's kind of up to you. Okay, so these I'm just rewriting. Minus 216b to the cube plus 90b squared minus 4. 5 times 12b to the squared is 60b squared. Then I have 5 times a -24. Is that 120? I believe. I think I did this one different before. I think 5 times 24 is 120. Then 5 times another negative 24 is minus 120. 5 times 48 is 240. 5 times 12b is 60b. And 5 times 34 is 170. So now I have everything multiplied out, and I have to try to combine my like terms, okay? The only thing that I have that has a b cubed is the negative 216b cubed. But notice I have a 90b squared plus 60b squared, and actually those are the only two. 90 plus 60 is 150b squared. And I think what I'm going to do next is combine my b's. So I'm going to go negative 120 minus 120 is negative 240 plus 60 would be negative 180b. And then I have a negative 4 plus 240, which is 236, and then minus 170, which I believe would be 66. And that would be a, how am I doing this? Oh no, I'd be adding, hold on. Oh, I went negative 4 plus this, so I got the 236. So it's positive 66. So let's see if we got that right. We did. But like I said, that would be one that would be easy to make a mistake on. That's what I think is the worst part of today. Gavin?
At the beginning, why did you have to split up
The two problems?
the 2b and negative 4?
Oh,
It's more on the right side.
Because it's square.
How about other things are squared?
Okay.
I get it.
are you sure?
Yeah, because that's the more. I get it.
Everybody get it? I don't know if I really understand your question there, but you get it now. Okay. All right, so let's go down here. The last thing that we're going to learn today is by looking at a graph and looking at its equation, what would its graph look like? So just looking at something, you would be able to tell how the graph would kind of look, okay? And that's what we're going to learn. The first thing I think you guys are all really good about right now is that anytime there's a 0, that's where it crosses the x-axis. It's also called the root. It's what you get if ever you solve something, but those are the zeros, okay? Now, if a function, if the highest power of a function is n, that function can have at most n zeros. So here's what they mean by that. If you had x to the 5th minus 3x squared plus 2, okay, the most zeros that this could have is 5. But it doesn't have to have that many because some of the times your graph is going to turn, and some of the times when it turns, it won't touch the x-axis. And so not all the time does it touch there, so those aren't zeros. But if it's 5th, that's the most zeros you could have. The other thing is that your graph has these turning points. So if you looked at this one, here's a turning point that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? If it has 9 turning points, that means that it is n to the 10th or higher. Okay? So if you had an n to the 10th, it could have at most 9 turning points, but it would not have to. That's just the most it would. Here, if you look, there's 1, 2, 3 turning points. And then if we look where it crosses the x-axis, it has 4 zeros. So it has 4 zeros, it has 3 turning points. So my guess is the highest power of x here is going to be to the 4th. Okay? Now, even polynomials. We have to talk about this. What an even polynomial is that your highest power of your variable, that degree, is going to be even. And this is super important. When that is even, whatever direction your graph is going on the right side is what direction it's going to go on the left side. On the right side, this is approaching negative infinity, and because it's even, on the left side, it's going to approach negative infinity. If we look here, again, on the right, we always look on the right first. It's approaching negative infinity, as well on the left it is. Now, when you have an odd degree, like notice this one has 3 zeros. I would guess this is an x to the 3rd because it has 2 turning points. It's always 1 less than that. When it's odd, you look at the right side first. This keeps getting bigger and bigger, so it's approaching positive infinity. So here it does the opposite. When it's odd, if it approaches positive infinity on the right, it does negative infinity on the left. Same thing here. Notice this one has only 1 0, but do you see how it has 2 turning points? I would say this one too is x to the 3rd because it has those 2 turning points. It just so happens that this does not go up far enough to touch this, okay? That has odd, so we look on the right and this is approaching negative infinity. So on the left, it should do the opposite and it approaches positive infinity. Now, I don't know if you guys have this graph on the page you're on right now. It's on your cheat sheet and it might be on the next sheet. I think I switched my 2 pages because I like this graph better, okay? And this is on your cheat sheet. So when they are asking you for n behavior of polynomials, you look at 2 things. You look at your positive or your leading coefficient, okay? And you look at the degree of that leading coefficient. So you'd have to have a positive number 4 and an even coefficient. So let's just say it's x squared minus 8, something like that. So we look at 2 things. This is a positive leading coefficient. This is an even degree. Now, the first thing you look at is your leading coefficient. Is it positive or negative? Whatever it is, that tells you what your graph is going to do on the right side. If it's positive, your graph is going to get bigger and bigger and bigger, and it's going to approach positive infinity. Okay? The second thing you look at is your degree. In this case, it's 2. If it's even, your graph goes in the same direction on both sides. So this approaches positive infinity as well as that does. Now, if we go down here to an odd degree, we could make that just 4x cubed minus 8, let's say. We still have that positive leading coefficient, but now we have an odd degree. The positive leading coefficient tells us what we do on the right side. If it's positive, it keeps getting bigger and bigger. If it's odd, the 2 sides do the opposite. So if it's going up on the left, on the right, it's going down on the left. Then when we get to a negative leading coefficient, so let's just make this negative 4x squared minus 8. Okay, we still have an even degree. What's changed here is this is negative. This tells us what happens on the right side. If it's negative, it's going to go down and it's going to approach negative infinity. Then if it's even, it does the same thing on both sides. Okay, down here, we can just make that one negative at the beginning. The negative at the beginning tells us what happens on the right. If it's negative, it approaches negative infinity. If it's an odd degree, they do the opposite. So this approaches positive infinity. And then these notes right here. So your highest degree obviously is either even or odd. Do you have these on there? Okay. If it's even, your left side and your right side are the same. We saw that here. Oh, no. Go up a little bit. Even, we saw that left and right are doing the same. If it's odd, and I talked about this, the right side and the left side do the opposite. Is that okay? Do you guys get that? Everybody get that? So this next page kind of just talks about those same things. So here is just another way of looking at that chart, but I liked the one we did first, that first page. So we're not going to talk too much about this, except that they're going to have us write our end behavior like this. So this one's odd and negative. Negative tells us it's going to go down to negative infinity here. If it's odd, it does the opposite, so it approaches positive infinity here. So how we would write our answers today is that as f of x approaches positive infinity, which is right here, notice our graph gets smaller and smaller, so it approaches negative infinity. As our x approaches negative infinity, notice our graph is getting bigger and bigger, so it's approaching positive infinity. So we're going to do that. All right, so let's go here. And this is what your last type of questions are going to be like. So this says, describe the end behavior. When they say that, this is what you have to write out. Okay? So remember, it would be as x approaches positive infinity, your f of x approaches what? Is this getting bigger or smaller?
Negative.
So negative infinity, right? And then as x approaches negative infinity here, what's happening there? It's approaching negative infinity. Now, do you see how they do the same? Does that mean that it's odd or even? Even. And then we're going to look at the graph and see how many zeros we have. And it says real zeros, so that means what zeros are crossing the x-axis. So do you guys agree we just have 2? And then this one right here would be an imaginary zero, like with an I. Okay? All right, so let's look at this. Again, when they say end behavior, this is what you do. As x approaches positive infinity, this approaches what? Negative infinity. And as x approaches negative infinity, our f of x approaches positive infinity. Do you notice how they're different? So which of these would it be? Odd. Good. And number of real zeros here, we have 1, 2, 3, 4, 5. Everybody good there? Okay, then I think we're on our last page. Yes. Okay, so same thing. Actually, yeah, this is exactly the same thing. So here, as x approaches positive infinity, our graph is approaching positive. As x approaches negative infinity, our graph is approaching positive. See how they're the same? What degree would that be? Even. Number of zeros would be where it crosses the x-axis. 1, 2, 3, 4, 5, 6. Okay. And one more. Here, as x approaches positive infinity, our f of x approaches negative infinity. As we approach negative infinity, it's approaching positive infinity. These are different, so is it odd or even? Odd, and it has 1, 2, 3 real zeros. Okay, oh, down here. All right, so your assignment is this. So did you think this was hard today? No? Except for that one question was kind of yucky. Oh yeah, so those worksheets, did anyone want me to put them in for you, or do you want to put them in on Schoology? Either way is fine with me, okay? And if you already put them in Schoology, that's fine. You can just keep them there. Yes. They're due tonight at midnight, just so you know. So if you didn't get them done yet, that's okay.
I guess you're cool.
You sure?